Hi guys, as I promised, here I am doing one of the Doppler problems for you. Problem number 61, and this is one of the problems that I posted on Blackboard. So I would like you to pause the video and read the problem first. And I believe that you did it. And at this point, what you have is a bat flitting about in a cave, navigating via ultrasonic bleeps, and his frequency is 39,000 hertz, and during one fast swoop directly toward a flat wall surface, the bat is moving at 0.025 times the speed of sound in air. So what I did here was I started with the general equation that we have, f of observer and the frequency of the source, and then velocity of the sound plus or minus the velocity of the observer divided by the velocity of the sound, again plus or minus velocity of the source. And the first thing is that you need to understand what are the given information. First of all, we have to understand that the source here is the bat, and the bat is emitting a frequency 39,000 hertz, and in this case the observer is the flat wall. I know that it is not really an animated thing, but in this case the observer, we take it as the flat wall, and the wall is not moving anywhere. And if you look at the velocities, the velocity of the sound, I took it as 340 meter per second, and then the velocity of source, I took it as 0.025 times 340, because that is what is given to us, 0.025 times the speed of sound. And then the last thing is the speed of the observer, which is the wall, and it is not moving, as we all know. And there you have the speed of the actually it's the observer, sorry, the speed of the observer given to us as v o, or v of observer, equal to 0 meter per second. So the first thing that you do is take equation and substitute the known information. All right, so the first thing, if observer, we don't know that, so let's start substituting what we know. F observer and f of source 39,000, and the speed of sound 340 meter per second. And I'm going to leave this plus or minus here for now, and I'm going to erase it later. And then the speed of sound is speed of the observer is 0. Actually that plus or minus doesn't really matter, since we are adding a 0 to it. And then down here we have 340 again, and plus or minus, and then the source speed is 0.025 times 340. So I'm going to find it in and then get back. So I got it at as 8.5, and that's what I have now. Now we need to decide what sign that we are using. Now remember, the bat is flying toward the wall, and assuming that the wall is the observer, because of the bat's motion, we have the wall should be able to hear a louder sound, right? So the source is in the denominator, and the source is moving toward the observer, so we are expecting a louder sound here, right? Now if you make the denominator bigger by using the plus sign, then the frequency of course goes down, because if you have 1 over a bigger number, that actually makes the frequency getting lowered. And because of that, we have to choose the negative sign, and by choosing the negative sign, we are reducing the size of the denominator, and 1 over a smaller number gives us a relatively bigger number, right? So that's the fact. Now, most importantly, we have to take each of these separately. So here we have the source in the denominator and the motion of the source. If it is toward the observer, then we are choosing the negative sign. If it is away from the observer, we take the positive sign. And that's what we discussed in the class, and I hope you remember that. Now the next line, I am using the negative sign, and I am rewriting the equation 39,000, and the numerator is easy because adding or subtracting a zero doesn't really matter. And then here you have, and down here we have 340 minus 8.5 as we picked a negative sign, and that gives us 331.5. So let me write that. 331. Oh. .5. And now you can do the substitution, use the calculator and find this value. And we end up with a nice rounded number, 40,000. So now remember, this is the frequency as heard by the observer. But we are not done yet. The question, if we go back to the question again, the question asks us, what frequency does the bat hear reflected off the wall? Now this is the part where you need to pay more attention on, because you know this is more like the police radar that we were discussing in the class. So here the bat is emitting a signal and it is getting bounced off of the wall. And the second round, the wall is emitting because it is reflected off, right? Now the second time, the wall is emitting the sound and bat becomes the observer. I hope that makes clear. So I am going to rewrite the information. The second round, F of source is the wall. And what frequency does the wall reflect? Well, we already found what the frequency as heard by the wall as 40,000. So here you have 40,000 hertz. So I just wrote this as the wall because the second time the source is the wall and the second time the observer is the bat, and that's what you are looking for. And the observer is now moving at the velocity of 8.5 toward the source, 8.5 meter per second. And if you are wondering from where this 8.5 is coming from, the same thing, the speed of the bat. And now he is the observer, not the source. And then again we have the source speed, because that's the wall and that is not moving, and it is 0 meter per second. And yeah, so that's that. And the speed of sound does not change and it stays as 340 meter per second. So the second round, now I am going to draw a little line over here and to separate the two. And we are using the same equation as before. So let me write the full equation just to practice. So F naught equals, or F observer equals F source V plus or minus and the observer V plus or minus and the source, right? So this is the equation. And now we again substitute the values that we have. So F observer, now observer is the bat and the source is the wall and it is emitting 40,000. This is the frequency in the first time that we found as 40,000 as the observed frequency in the first part. But in the second part, since it is reflecting the sound, we take it as the source frequency. And then V is 340 and the observer is now moving at a speed 8.5 meter per second. I am not using the units here because that actually makes the equation little messy, but you know that I am using all SI units. And then down here you have 340, and source velocity, source is the wall, therefore it does not have any I mean it is stationary, so the value is 0. So let's do the substitutions and then decide on the sign. Now we have the bat who is the observer, and he is actually in the numerator. Now the observer is in the numerator, and the observer is moving toward the source because the bat is coming toward the wall, and as a result of that he should be hearing a louder sound, and the louder sound creates by the positive sign on the numerator. So I am using 340 plus 8.5. So I am this part actually is not physics, guys. It is simple algebra, and the understanding of numerator bigger, the value is bigger, denominator smaller, value is bigger. So that is just the basic understanding of algebra. That's the knowledge I am using here. Nothing to do with physics. I mean, of course the physics part is like, you know, just the general understanding. When someone is moving toward a source, the value the frequency is higher. When someone is moving away from the source, the frequency is lower. So that's the understanding that we have from the physics point of view. All right, so let's use these values in the calculator and find the final answer. And the final answer is 41,000 hertz. So that's that, and we can box this, and this is the final answer. So remember, a bat is flying toward a wall, and he while flying he is emitting a sound, and the frequency of the sound is 39,000. Go back to the problem and read it. And the wall is reflecting the sound off, so the reflecting sound is heard by the bat, and so the frequency as heard by the bat is 41,000. Now this is actually how the bats navigate. They don't they are usually called as blind animals. So they just emit the high frequency waves in order to find their way, and that's how they do it.